Have you heard of GOM? Well, GOM are metrology experts. They are innovators. They are market leaders in the scanning technology and solutions that they offer. And today MTD CNC have travelled to their UK headquarters in Coventry to find out more. Kevin, why GOM?
So GOM as a company, just to give you a little bit of a background, I've got over 20 years experience in optical metrology, from starting out with being privately owned with a focus on the best possible data quality. With a recent acquisition by Zeiss, we're now in a position where we've got a great portfolio to offer people. This goes from handheld metrology with the Handson Metrology channel, with handheld laser scanners, through the structured light ATOS scanning systems and testing products, all the way through to fully automated systems working in line. And the focus of all of this is really best-in-class technology. And the one thing which is common across all of this is the software. Software really today is a differentiator for everything. It's what we interface with, it's what it really drives the user experience. And with the kind of free software downloads that have happened around the world for many years now, we're in a fantastic position in terms of the quality of our software. The ScanBox is automated scanning. A lot of people might know GOM for the mobile manual ATOS scanning systems, and as they got well established and accepted, we needed to automate it. And the best way to do that is to have standard products. So standard ScanBox means we've got the scanner, the robot, and all of the software developed and delivered from GOM. So the question, why are people investing in scanning-based metrology, comes really to the changing in complexity of parts and the research and development drivers. Ultimately, the information you can get out is, we call it information-rich reports. It's taking the reporting to the next level. So if I can help you as a manufacturer to launch a product quicker or to improve the quality of that product, then that's what the ScanBox and the scanning technology is giving people ultimately.
One example of a solution that we're provided with a ScanBox would be a nozzle guide vane, or NGV. So this is contained within a aircraft engine and has been run for many tens of thousands, hundred thousands or many millions of miles. So after a while it has a life cycle and it's been put through many stresses, and we need to understand from this surface what has happened to this particular part over its life cycle. We can then deduce whether this can be put back on the engine in its original state, whether it needs to be reworked, or whether it needs to go in the scrap bin. So our inspection technologies are able to give us the full field data required to capture all of the surface and understand where any stress raises are, or any discoloration of the surface, to provide some understanding as to whether this part will perform as it should be in the engine.
And how does this work with the ScanBox? Give me more detail.
So the ScanBox will be able to capture a digital twin. So essentially, whatever is the hardware, we can replicate that as a mesh or a surface that can then be archived, inspected at a later date, compared back to the same exact part when it's been put on the engine again, and then that is then tracked throughout its life, and then we can keep records of that relating back to the part number.
Now, in regards to the ScanBox, how does it improve manufacturing? Okay, so I think people look at a machining centre and time to measure a part or machine a part, it can be quite clear, and the return on investment is calculated quite quickly. We can look at it the same way with scanning. But if there's a lot of applications where we can take a lot of time out of the inspection process, but there's other angles as well where cost savings are massive. If we can, when we're producing these complete colour plot style inspection reports,
these are really the ultimate gatekeeper. If you want to stop a bad part leaving your factory, affecting your reputation and giving you incurred costs down the line, you know, that's got to be one of the best ways of stopping that from happening. We can look at things like adaptive machining as well, so really making sure that every part cleans up with, you know, very high value components. So there's many ways that the technology can really save money and pay for itself in a timely way. The thing with those reports is just how fast they can be interpreted compared to traditional style reports. And you don't have to it's not just the measurement guy that can understand them quickly. You can have a tooling engineer, a manufacturing engineer sat around the table, look at those reports, and in a few moments understand exactly what the problem is. And we've had, you know, multiple customers present case studies where they're effectively taking out complete quality loops, and that's not just, you know, a few minutes of time, that's days or weeks of time, because of the information-rich reports that the systems are delivering.
Ben, why have GOM introduced Handson Metrology in partnership with Zeiss?
So GOM have introduced Handson Metrology with Zeiss for there's various different reasons. It gives us a new level of portability of our products. They're a lot lighter. We can, you know, take them in the boot of the car, start to move around, you know, larger parts, especially with the handheld scanner in front of us as well. It gives us a new avenue to go down when measuring parts.
Ben, sounds very impressive. Can you give me a demonstration?
Yeah, of course. Yeah. So we've got a simple part here. I'm just going to capture a clipping plane so I don't pick up any of the rotary table there. I'm going to, all the controls are at your fingertips, which is great. So if you're working at a distance, you don't need to go back to the laptop. One press of the button, you'll notice on the screen we're collecting a mesh, and I simply just work my way around different angles, you know, gathering what I need. There are different levels of resolution lasers as well built into this, which is nice. So if I did need to get in some smaller holes, I could switch to maybe a single blue line or a single red dot line. But essentially, you can see on the screen there, I'm capturing the part.
What kind of size parts can you measure up to?
Essentially anything that, you know, fits in the size of your hand, up to larger applications like a full car. As you can see, it's on a long wire here, so we can move around. So yeah, the possibilities are endless. On the Handson Metrology website, you'll see some extremely large applications which look more like oil and gas, scanning different turbines and stuff as well. So yeah, if you're brave enough to climb up a ladder, you can get what you need.
Brilliant stuff. Thank you, Ben.
That's all right.
At GOM, we use portable scanning applications for design studio work, so models such as this one. That's one of the very first applications that GOM were involved in. We can use the portable system to inspect pretty much any part, from something small that can fit in your hand up to a full-size vehicle.
So reverse engineering is one application, and also prototyping.
That's correct, but we go beyond that. So we use the systems for inspection, first article inspections, and inspection of finished products. So design element is obviously the very first stage, but we see the component throughout the entire manufacturing process.
And how easy is it to set up and to use?
It's very easy to use. It's literally plug and play. Once the machine's warmed up for a couple of minutes, we can start taking scans. So I've got a little remote control here, and I can take a measurement.
And how accurately can you scan components too?
The accuracy will depend on a number of factors, but typically, as a rule of thumb, on something like this, we're looking at about tens of microns over a metre.
And is one of the main benefits of having this portable scanning technology so you can actually go to the part rather than take the part to an inspection area?
That's correct, but you can build from that. So you can start off with a manual system and then upgrade it to an automated solution, such as one of our scan boxes.
See, we want to find out a little bit more about this technology. Can you explain to our audience how it works, please?
Yeah, sure. So what we're looking at here is the GOM testing portfolio. So the main product in this is the ARMA system. It's a system that basically measures our customers' tests using a principle called DIC, or digital image correlation.
And can you go into a little bit more detail? What does that mean?
Sure, so when we look at doing a DIC measurement, we need to make sure we've got a speckle pattern on the part. So first we would prepare the part with a speckle pattern, and then we would perform the customer's test, whether that's a materials test or a component test, and we would put their part through its paces and basically see what happens, so we can measure either displacements on the surface or strains. Anything that the customer is interested in measuring, we can measure with the ARMA system.
So I hope that that has given you an insight into what GOM do. They're certainly innovators and market leaders with the technology and solutions that they supply. But it's not just about the technology, it's about the people behind the technology, with experts and specialists in every field. It's great to see how metrology can add value to your manufacturing process too. I hope you found this video interesting and educational.